In this video, we are given that at 5% per year interest, how much money will there be in 10 years if the initial investment is $1,000 and interest is compounded yearly, quarterly, monthly, weekly, and daily. For periodic interest collection, we have a special formula. Amount of money after T years, let's call it P of T. Amount of money in an account after T years is going to be P of T is equal to P0. P0 is the initial investment, in our case $1,000, times 1 plus R over N. R is the interest rate. N is the number of times in a year interest is collected. The whole thing raised to the power NT. N times T. Once again, let me go over this formula a little bit. P of T is equal to, so P of T is equal to P sub 0, meaning the initial investment at time T is equal to 0, times 1 plus R over N. R over N. R is the interest rate given in year, in our case 5%, and N is the number of times you collect interest in that 1 year period, and T is the time in years. Okay, now let me go ahead and solve these problems, all of them. Once you know how to use this formula, these problems become really easy. So let's do A. Let's find the parameters here. P sub 0 is equal to 1,000 initial investment. Then T is 10 years because is given how much money will there be in 10 years. R is the interest rate, which is going to be 5%. You have to express, by the way, you have to express it in decimal form, 0.05, not as 5%, just 5. Now these parameters are going to stay fixed throughout all of these parts of this problem. Okay, so only thing is going to change how often you are collecting interest. So in part 1 you are collecting interest yearly, so that means your N is going to be just 1. So in that case your P of 10 is going to be P naught 1,000 times 1 plus 0.05 over 1 to the power N times T. N is 1 times 10. And if I simplify this, I'm going to get the following. It's about 1628.89. Now let's do part 2. Everything is the same, but this time we are collecting interest quarterly. How many quarters are there in a year? There are 4 of them. So N is going to be 4. So your P of 10 in this context is going to be 1,000 times 1 plus 0.05 over N, this N. Now my N is 4 and is going to be N times T is going to be 4 times 10. That's what it is going to be. And we get 1643.62. I'm rounding it to second digit. Now let's go ahead and do the next one. Part 3. Everything is the same. We are collecting interest monthly, so it's going to be N is equal to 12. Why? There are 12 months. So it's going to be P of 10 is going to be 1,000 times 1 plus 0.05 over 12 raised to the power 12 times 10. And that gives me about 1647.01. Now the rest of the problems I'm just going to quickly write down and give you the answers. Is exactly the same. In part 4, your N, we are collecting interest weekly, is going to be N is equal to 52. Okay, and if we simplify it, this is what we are going to get. P of 10 is equal to 1648.3 0.33. So for daily, you're going to have this n is equal to 365, and if you plug this into the equation, you'll get 1648.66. Now, I have given you up to daily, but who said that you have to stop there? You can compound interest as frequently as you want. What if you compound interest every instant? That means continuously. That means every moment of the day you compound interest. Not daily, not monthly, or not weekly, not every second. Even it could be every billionth of a second. So you can continuously collect interest. In that case, this formula, by the way, changes, and this becomes this. P of t is equal to P naught times e to the power RT. E is the Euler's constant, which is 2.7172, and R is the interest rate in years, and T is the time, total number of years. So this will become, in the continuous case, continuous collection of interest, right, is going to be P of 10 is equal to 1000 times e to the power 0.05 times 10, which, by the way, is equal to 1648.72. 1648.72. Now let me go ahead and summarize everything and put things in perspective. Look, if I collect interest basically yearly, after 10 years I should have 1628.89. If I collect more often, that means 4 times a year, quarterly, I get slightly more money, 1643.62. If I collect interest more frequently, let's say once a month, I get 1647.01. See, these numbers are increasing. The more frequently you collect interest, the more money you will get. Now, if you collect every week interest, then it's going to be 1648. If you collect daily interest, by the way, after 10 years, you're going to have 1648.66 in the account. By the way, most of the credit cards that you use, pretty much all of them, they collect interest daily. It's not yearly. They will give you the yearly rate, which is like 5%, but they will collect or compound interest daily. That means they're going to charge you interest on a daily basis. As a result, the money you pay is converted to yearly is going to be higher than 5%, slightly higher than 5%. Now, what if you don't collect interest daily, but you collect interest continuously? In that case, you will get the highest amount after 10 years, which is 1648.72. And this is how it works. So this is a very important problem. It has a lot of real-world application in the financial world, and also your money, right? That's important. Banks work exactly like this by using these types of calculation. They give you interest, they charge you interest using these types of formula, and you should have a very solid understanding of this. I hope that this discussion was helpful. Thank you very much.